Shown below is the velocity versus time graph for a toy car moving along a straight line. What is the maximum displacement from start for the toy car? So remember that on a velocity versus time graph, displacement is represented by area under the curve, or more accurately, the area bounded between the graph and the x-axis. So in this case, the displacement of the toy car for the first 2.5 seconds is entirely positive, as represented by this positive area. Then after the first 2.5 seconds, it looks like that displacement starts to add back in the negative direction. So the maximum displacement from start for the toy car is going to be right here at this point, because this is the point when the car stops traveling in the positive direction. So for the first 2.5 seconds, the car is traveling only in the positive direction, and it's gaining positive displacement. And then after the first 2.5 seconds, the car starts to gain some negative displacement, or in other words, it starts to travel back towards where it started. So the maximum displacement will be here at 2.5 seconds into the car's journey. Now to find the displacement at this point, all we need to do is calculate the area, or should I say areas, of some simple shapes. So we've got a couple rectangles and a couple triangles. So if we calculate all of these areas and add them up, we will get the displacement of the toy car up to 2.5 seconds. So let's do that. So first we'll start with the triangle in the top left. Remember, area of a triangle is 1/2 base times height. In the top left, the base is going to be 1 second. The height is going to be 2 meters per second, so it's the difference between 4 and 2. So it's 2 meters per second. This is equal to 1 meter. Next, we'll do the rectangle on the left. The area of a rectangle is length times width. The length is 1 second. Or I guess we could say the width is 1 second. Doesn't matter, the order is unimportant. Then the width or length, whichever dimension you want it to be, is 2 meters per second. So the difference between 2 and 0 is 2. So this is 2 meters. Next we'll do the rectangle in the middle. So the area of that rectangle is again length times width. One of those dimensions is going to be from 1 second to 1.5 seconds, so it'll be 1/2 second. The other dimension will be from 0 meters per second all the way up to 4 meters per second, so 4 meters per second. And that's equal to 2 meters. And then finally, we'll find the area of the triangle on the right. So it'll be 1/2 base times height, where the base is from 1.5 seconds to 2.5 seconds, so that is a total of 1 second. And the height is from 0 meters per second to 4 meters per second, so 4 meters per second. That is equal to 2 meters again. So if we add all of these displacements up from all of these areas, the total displacement is going to be equal to 2 meters plus 2 meters plus 2 meters plus 1 meter, which is 7 meters. So this is the total displacement up to 2.5 seconds, and it's also the maximum displacement from start for the toy car.